Hello everyone. Today we are going to discuss the problem find the frequency. So it is a difficulty easy problem. So the question description is given an array ARR of positive integers and an integer x. So we need to return the frequency of x in the array. So frequency means the count of x in the array simply. So the input one is ARR 11111. So totally the array only contains 1 5 times. So x is equals to also 1. So simply the output is 5. The frequency of one number is 5 times. So input 2 is 1 2 3 3 2 1. X is equals to 2. So we can see the each element 1 2 3 repeated 2 times. So the frequency of 2 is also 2. Frequency of number 2 is 2 times. That's it. So coming to the constraints, time complexity is big O of n. So and space is also big O of 1. So we need to solve this program in big O of n and with not taking any extra space. We can see this program is asked in the Google, which is a very big company, MNC company. So now, what is the approach? We discussed this similar kind of approach many times. So first of all, things used. For any question in which we need to find the frequency of any elements in the given array or list or collection or any count kind of thing, we just simply use a hash map. Blindly we go with a hash map which is optimized. So hash map, and to iterate the array we use loops obviously, and we use conditions to check with the x parameter for its frequency. So now steps means first one, to use an hash map we need to declare one. So declare hash map. Compute the frequencies into the hash map. We can compute the frequencies using a simple loop or a for each loop and the hash map with some inbuilt methods. So next, again use to the approach we are discussing is the approach 1. Iterate the array and find the x iterate the hash map and find x frequency. X frequency. Output is the frequency. So it is approach 1. So approach 2. So we are going to discuss two approaches. The first one is universal for any frequency kind of problems, but in this question it is not that optimized or not that good because the space constraint, which is big O of n, is not satisfied. So that is why we are going with the approach 2. So the approach 2 is going to be a simpler form and efficient for this particular problem. So things used is a variable to store count, loop to iterate, and condition to check if a number is equal to x. So declare a variable named count which is of integer type. So count is obviously integer type. So iterate the array using the loop. So find if each or any element during the iteration process is equal to x. If equal, so increment the count by 1 if the number x is found one time during the iteration, and sequentially go like this. So the output is the count. So this approach is more optimized than this approach for this particular question. So we are going to follow the approach 2. So what is the approach 2? So declare a variable count. So count is integer type, count is equals to 0. Next, iterate the array using the loop. So the loop is for loop, the simplest form of for loop, the for each loop. Integer n from the array. What are the sequence of values coming to the n variable from the array? If you see in the first example, it is 1, 1, 1, 1, 1. That's it. So each and every time we need to write here that find if each element is equal to x. So each element means n is equal to x. What to do? If they are equal, then increment by 1. So count plus plus. This means count equal to count plus equal to 1. That's it. So the output is a count. So return. So sample test case, it is passed, and hidden test case, so we can say the test cases are passed. So if you compare the complexities, the approach 1, time will be big of n, which is matching with the constraint, but space is also going to be big of n. This is the issue. But in approach 2, we will derive from the above, but first write here big of 1. So even though the time is same approximately, or the big of n, but the space, it is taking a constant space, which is the variable. So this is why the approach 2, which we wrote here, the logic is more optimized than the approach 1 solution. So how? So we know that a single variable will always a 4 bytes memory, which is static. So big of 1 space, and this loop individually take big of n because of the variable number of iterations. So that's it. So final time big of n, final space complexity is big of 1. So you can see time and space both are matching with the constraints. So this solution is acceptable with the given constraints and the problem. So we discussed 2 approaches neatly, and also compared which approach is better and suitable for this given particular problem. So approach 2 is suitable. So we wrote the code in the approach 2. So problem link is given in the description. Kindly go and practice the problem now. Thank you for watching.